Hi, in this video lecture, we will go through the topic vapor pressure of liquid solutions. Right? We know that vapor pressure is, in simple terms, vapor pressure is the pressure exerted by vapors, right, above the liquid surface, right? And vapors are formed when the liquid evaporates, right? When liquid changes from liquid to vapors, gaseous form, right? So now let's see how this process exactly happens, how this vapors form, and what is the vapor pressure exactly. We know that suppose we take liquid in this container, right, and we know that from the kinetic theory, we know that the liquid consists of liquid molecules that are randomly moving inside the liquid, right? And these liquid molecules, all these liquid molecules do not possess same kinetic energy, right? They possess different energies, right? And when these molecules collide with one another, they transfer energy from one molecule to another. And let's now talk about the molecules that are at the surface of the liquid. The molecules that are at the surface would be attracted by the molecules that are below these, right? We know that the liquid molecules have intermolecular force of attraction, right? That is, they attract one another, right, with the force. So the liquid molecules would be attracted by the molecules that are inside it. The molecules that are at the surface would be attracted by the molecules that are inside it, right? And when the molecules that are at the surface of the liquid, when these molecules will acquire high enough kinetic energy so as to overcome this force of attraction, these molecules will escape or move into gaseous state, right, where it forms vapor, right? These molecules are attracted by molecules inside, and these molecules also possess kinetic energy, right? So the molecules that possesses high enough kinetic energy, right, so as to overcome the intermolecular force of attraction between the liquid molecules, those molecules will move into gaseous form and will form vapors above the liquid surface when the kinetic energy is greater than intermolecular force of attraction between liquid molecules. Such molecules will move or escape into gaseous form and will form vapors, right? And this process is known as evaporation, right? Now, the molecules of liquid that will form vapors would be like this, right? And some molecules that are near the liquid surface, those molecules has tendency, those vapor molecules or the vapors which are near the liquid surface have tendency to enter back into liquid, right? So the molecules that are near the surface would be attracted back into liquid, right? So these vapors that are entering into liquid, changing into liquid form, right? So here the vapors are changing into liquid form. This is known as condensation, right? So this is evaporation, and the other process that is occurring here is condensation, right? So these two are spontaneous processes, right? So now look at this diagram again. The molecules, suppose there are some number of molecules, when some of the molecules at the surface will leave or escape into gaseous form, right, to form vapors, the kinetic energy of the mean kinetic energy of all the of some of the molecules or all the molecules will decrease, right? So kinetic energy, or we say this mean kinetic energy, let's understand this mean kinetic energy will decrease, right? Due to which when the kinetic energy of molecules will decrease, the temperature will fall. Why temperature will fall? Because we know that kinetic energy is directly proportional to temperature, or temperature is directly proportional to kinetic energy is directly proportional to temperature. That is, when we will increase the temperature, kinetic energy will increase. Now when kinetic energy decreases, temperature will also fall, and when temperature will fall, the rate of evaporation will also fall down, right? So slowly these liquid molecules that are at the surface will leave the liquid surface and will enter into gaseous form. So vapors will start increasing at the surface. That is, the concentration of vapors above the liquid will start increasing, right? And when the concentration of vapors increase at the surface, the tendency of vapors to condense or to get attracted back into the liquid will increase, right? So slowly what will happen, first the rate of evaporation is high, right? So when there are enough vapors above the liquid surface, the vapors will start condensing back into the liquid, right? So at one point of time, the rate of condensation will be more than the rate of evaporation, or we say that the rate of condensation will increase compared to the rate of evaporation, right? So at one point of time, when the rate of condensation is equal to the rate of evaporation, we say that the equilibrium has been attained, right? So when condensation is equal to evaporation, when when evaporation is equal to condensation, equilibrium has been attained, and the vapor pressure above the liquid surface, right? The pressure exerted by the vapors above the liquid surface at equilibrium is called the vapor pressure of the liquid, right? So the pressure due to vapors above the liquid surface at equilibrium is called as the vapor pressure, right? So we say the pressure exerted by the vapors in equilibrium with the liquid at a given temperature is called vapor pressure, right? Now let's understand some more things. We know that the molecules of liquid there are intermolecular forces of attraction that is acting between liquid molecules, right? So due to this intermolecular force of attraction, different molecules, different liquids have different intermolecular force of attraction. So due to which all different liquids have different tendencies to change into vapor forms. The liquids that have high intermolecular force of attraction will vaporize at a lower rate compared to the liquids that have weak intermolecular force of attraction, right? For example, chloroform has low intermolecular force of attraction, the chloroform evaporate at a faster rate compared to water, which has high intermolecular force of attraction, right? So factors affecting vapor pressure. So this intermolecular force of attraction is one of the factors that can affect the vapor pressure, because more is the intermolecular force of attraction, less molecules of liquid will move into or will escape into vapor phase, right? The second is temperature. Since I said at the beginning that the molecules at the surface that possess enough energy or enough kinetic energy so as to overcome this force of attraction, right, would be able to enter or escape into the gaseous form to form vapors, right? I repeat, the molecules at the surface that has high enough kinetic energy, right, so as to overcome the attractive force so as to overcome the intermolecular force of attraction will enter into or will form vapors, only those molecules will form vapors. So when we increase the temperature, the kinetic energy of the molecules at the surface will increase, right? Since the kinetic energy is increasing on increasing temperature, more of liquid molecules would be able to enter into vapor form, would be able to escape into vapor state, right, and form vapors. So due to increase in temperature, the kinetic energy of the liquid molecules at the surface will increase and more liquid molecules will enter into vapor phase, right, and hence the vapor pressure will increase due to more liquid molecules passing into vapor state. The vapor pressure above the liquid surface would increase with increase in temperature, and this is quantitatively, this is given using this Clausius and Clapeyron equation. This is known as Clausius and Clapeyron equation that shows two vapor pressures P1 and P2. It shows vapor pressure P1 and P2 at two different temperatures T1 and T2, right? Now let's talk about boiling point. Boiling point is the temperature at which the vapor pressure of liquid will become equal to the atmospheric pressure. We know this definition from our previous classes. So the temperature, now just apply to this concept. The vapor pressure, suppose a liquid that has lower vapor pressure, right? So lower vapor pressure means lower vapor pressure, or we say suppose a liquid has high intermolecular force of attraction. That means less liquid molecules will enter into vapor phase, right? So the molecules that have low vapor pressure, that is low vapor pressure means high intermolecular force of attraction, right? So the liquids that have that have low vapor pressure, that have a low tendency to enter into vapor state, right, would need to be heated more. That is, those liquids would need to be heated to a higher temperature so that the vapor pressure would become equal to the atmospheric pressure, right? So the boiling point of those liquids whose vapor pressure is less or higher, right? Because if vapor pressure is high, we have to heat it more so that the vapor pressure would become equal to the atmospheric pressure, right? So that the liquid can boil. We know that liquid will boil when the vapor pressure would become equal to the atmospheric pressure, right? So the liquids that have low vapor pressure would have to be heated more so that the more molecules can enter into vapor state, right, and will contribute to the vapor pressure, right? So when you are heating it more, that means you are heating it to a higher temperature. Heating it to a higher temperature means the boiling point is high. So in simple terms, boiling point of liquids that have lower vapor pressure would be higher, right, as compared to the vapor pressure of liquids that have a higher vapor pressure. If the vapor pressure is higher, then it has to be heated at a low temperature comparatively so as to make its vapor pressure equal to the atmospheric pressure, right? So if vapor pressure of A is less than B, then the boiling point of A would be greater than B, because liquid A will have to be heated more to make its vapor pressure equal to atmospheric pressure, right? Now let's talk about the vapor pressure of solution. Now suppose in this case we were talking about pure solvent, right, which does not contain any solvent. Which does not contain any solute. So now let's take an example. Suppose we add salt to it. Let's take an example of solution. Right, and these are liquid molecules. When you add, these are liquid molecules, right, which are ready to evaporate. In the absence of any solute, these are liquid molecules. So when we add solute, say sodium chloride or any solute, to the pure liquid, what will happen is some of the liquid molecules would be replaced by the solute molecules when you add solute to it. Suppose these are the two liquid molecules that are replaced by, these are solute molecules that are replaced by solute molecules. So now we have less molecules of liquid at the surface. So less molecules at the surface means less molecules will go into vapor state. So less molecules going into vapor state means less vapor pressure, right? So due to addition of solute or due to the formation of solution, the vapor pressure of pure solvent would decrease, right? So we say the vapor pressure of solution is less than that of pure solvent. Why? Because some of the liquid molecules are replaced by the solvent, solute molecules, right? These are the solute molecules that have replaced these liquid molecules. Since they have replaced liquid molecules, we have less liquid molecules that can go into vapor state and form vapor pressure, right? So in this case, this is a solution, right? We have less liquid molecules. Less liquid molecules means less vapor pressure. So we say vapor pressure of solution is less than that of vapor pressure of pure solvent, right? So now, as we talked above, if the vapor pressure is low, that means, suppose this liquid boils at 100 degrees Celsius, right? Now boiling means the vapor pressure would become equal to the atmospheric pressure. Now suppose I add solute, the liquid molecules would be replaced by the solute molecules. Now we have less solvent molecules. Now to make its vapor pressure equal to the atmospheric pressure, we have to heat it more. We have to heat it at a higher temperature, right? So that more of liquid molecules can enter into vapor state, right? So here the boiling point has also increased. Similar is the case like we have discussed before. Since the vapor pressure of solution is lower, right, as compared to the pure solvent, so the solution has to be heated to a higher temperature so that its vapor pressure can become equal to the atmospheric pressure. So in other words, the boiling point of solution becomes higher compared to the pure solvent, right? So we say boiling point of solution is higher than that of the pure solvent, and this is known as elevation in boiling point, right? This is one of the colligative property that we would be studying in detail in future lecture, right? So this is known as elevation in boiling point. Just remember, due to this, boiling point would be elevated, right, of solution. Boiling point of solution would be elevated. Now let's talk about freezing point. We know that